Okay, here we've got a disproportionation reaction involving xenon, and it's here described as R8. And we're told that's in acidic solution. Okay, so that makes it quite, well, relatively simple. We don't have to add any hydroxide ions. Okay, so as usual, we're going to write the half equations and combine them to make the full ionic equation. And that's what we're going to do now. But so the first step, and this sort of question always follows the same steps. First step would be to look at the equation here and think about all the oxidation states. Okay, so we've got oxidation state of +6 here, right? So if you're not sure about +6, then work it out yourselves. I'm just going to save time. Xenon atom is 0, of course, and in Xe062-, then the oxidation state of that is +10. Okay, so that's the first stage, is to work out the oxidation states of the element that's being disproportionated. Okay, so then if we look at this turning into this, right, we can see the oxidation states going from +6 to 0, so that's reduction. So that's reduction, and then when HXeO41- goes to Xe062-, the oxidation state's increasing, which is not a reduction, right? So that's oxidation. All right, so there's our two, that's the foundation of our two half equations. So let's first of all do the oxidation equation. You can do them in any order, it doesn't matter. All right, and what we do is we write the HXeO4 on the left. It's the reactant, of course. Leave some space. It's a disproportionation reaction, so you don't really need much space. So leave some space, and then in the oxidation reaction, the product is Xe062-, like that. We're going to go through the same steps as we did before. Okay, Xe is already balanced. So next is to balance oxygen. We do that with water molecules. So we need an extra 2 on the left-hand side. So we're going to put 2 waters on the left-hand side in that nice little space. And then the next step is to balance hydrogens. And on the left-hand side, we've got 4, 5, right? We've got none on the right-hand side, right? So let's add 5 hydrogens to the right-hand side. And then last step in the half equation is to balance the charges with electrons. And you can see we've got a 1- on the left-hand side. And we've got 5 take 2 is 3+ on the right-hand side. So we have to make 3+ into 1-. So that's going to be adding 4 electrons. And now the charges are balanced. Okay, so that's the oxidation half equation. Let's do a similar job for the reduction half equation. Again, we start, because it's a disproportionation reaction, we start with the same reactant. Right, leave some space again, right, but this time our product is just xenon atoms. Okay, so xenon's balanced already for us. So the next step is to balance our oxygens, right? We've got 4 oxygens on the left, none on the right, right? So we're going to put 4 waters on the right-hand side. That balances our oxygen. Now we have to balance our hydrogens. We've got 8 on the right-hand side. We've got 1 on the left-hand side. So we're going to have to add 7 hydrogens on the left-hand side. Okay, last step is balancing charges. We've got +6 on the left. We've got neutral on the right, so we have to add 6 electrons to the left-hand side to make that left-hand side neutral, like so. Okay, so now we have our two half equations, and I'll change color. So the usual process to add the two together is to make sure that the electrons are going to cancel when you add them. All right, so we've got common multiples of 4 and 6, so we're going to have to multiply this by 6, and we're going to have to multiply that by 4. Right, so we're going to have 6 of these, going to have 12 of those. We're going to have 6 of these. We're going to have 30 hydrogen ions. And we're going to have 24 electrons. Okay, and similarly, we're going to have 4 of those. We're going to have 28 of those. We're going to have 24 electrons. Right, we're going to have 4 xenons. Right, and we're going to have 16 waters. Okay, so good. Now we can add them together. I'm going to change color again because before we add them together, we're going to cancel stuff out. Right, so the first step is cancel out the electrons. So 24 electrons on the left and the right are going to cancel out. But we can also cancel waters. Right, see we've got 12 waters in the oxidation reaction on the left-hand side, and we've got 16 in the reduction reaction on the right-hand side. So all of those can cancel, and that 16 turns into 4. So that's sorted our waters out. We can also cancel some hydrogens. See how we've got 28 in the reduction reaction on the left-hand side, but we've got 30 in the oxidation reaction on the right-hand side. So all of those hydrogen ions can cancel, and that 30 turns into a 2. And now we have the equation such that we can add it together. Okay, so we're going to have 10 HXeO41 minuses. That's all we've got on the left-hand side. Right, on the right-hand side, we've got 6 XeO62 minus. We've got our 2 hydrogen ions. And then we've got our 4 xenon atoms, and we've got our 4 water molecules, like so. And the last job is just to simplify it. All right, so let's switch back. This you can divide all the molar ratios by 2 just to simplify. So that will turn into a 5. That will turn into a 3. That will turn into a 1. That will turn into a 2, and that will turn into a 2. And then that last version is the final answer.